Hello everyone, so today we're going to be working on how to use different properties of exponents. So as you can see in the table, we've got a bunch of different properties and we're going to take a look at the definition of each and an example of how it's used. So the first one is product of powers. The definition of that is if you have two terms with the same base, so for example a to the m times a to the n, and they're being multiplied, that means that you add the exponents. So that would be the same as a to the m plus n. So for example, if I had x to the fifth times x to the third, that would be the same as x to the eighth, because 5 plus 3 equals 8. The next one is the power of a power property. The definition is that if I have a to the m raised to the n, that would be the same as a to the m times n. So for example, if I had p squared raised to the 9th power, that would be p to the 18th, because 2 times 9 is 18. The next property is the power of a product property. So for example, if I had a times b raised to the m, that would be equal to a to the m times b to the m. So for example, if I had jk to the 4th power, that would be equal to j to the 4th times k to the 4th. The next property is the negative exponent property, and that is, the definition is a to the negative m is equal to 1 over a to the m. So if you have a negative exponent, you want to move it to the denominator. So for example, if I had v to the negative 6th, that would be the same as 1 over v to the positive 6. This also is important to know if you had the negative exponent in the denominator of the fraction already, it would move to the top to become positive. The zero exponent properties definition is if you have a to the 0, that equals 1. No matter what you have raised to the 0 power, it always is equal to 1. So, an example, if we had f to the 0, that's still just 1, no matter what it is. Alright, then we've got the quotient of powers property. So the definition is if I have a to the m over a to the n, that's equal to a to the m minus n. So for example, if I had y to the 7th over y to the 4th, that would be equal to y to the 3rd, because 7 minus 4 equals 3. Then our last property is power of a quotient. So if I have a over b raised to the m, that's the same as a to the m over I want b down there, over b to the m. So for example, if I had t over u raised to the 10th power, that would be equal to t to the 10th over u to the 10th. So now we're going to get some practice simplifying some algebraic expressions with exponents. In order to be considered simplified when we're dealing with all these exponents, there can only be positive exponents, and each variable only appears once. So let's take a look at some of these examples. We're going to start with number 1. So since I've got this to the 3rd power out here, that means everything inside the parentheses is being raised to the 3rd power. So we need to use one of our properties from up above. When we have a power raised to a power, that means we have to multiply the exponents. So I have a to the 2 times 3 over b to the negative 3 times 3. 2 times 3 is 6, so I get a to the 6th. Negative 3 times 3 is negative 9. Now this is like what we talked about up above. If you have a negative exponent, you have to move that whole term. Since it's already in the denominator, I can't move it to the denominator, so that means I have to move it to the numerator of the fraction. And so this would be my final answer. Okay, now we're on to number 2. So again, I want to start with my parentheses first. What's important to note here, I've got negative y squared raised to the 5th power. If you have something negative raised to an odd exponent, so like we've got to the 5th here, then it's still going to be odd. So I'm going to just make a note of that. So an odd number, sorry, not an odd number, a negative number raised to an odd power is negative. It's important to remember. So here I've got negative raised to the 5th, so that's going to still be negative. And then I've got y squared to the 5th, so that would be y to the 2 times 5. Then I've got y squared times y to the negative 12th. We learned in one of our properties that when we're multiplying two terms with the same base, we add their exponents. So I have 2 plus negative 12. So now simplifying those, I've got negative y to the 10th, y to the negative 10th. So now I'm going to use that same property again where I've got two terms with the same base being multiplied, so I can add their exponents. So I've still got negative sign out in front. 10 plus negative 10 is 0. Anything raised to the power is raised to the 0 power is just 1. I still have to bring over, though, my negative sign. So my answer will be negative 1. Alright, now let's take a look at number 3. So since we have a fraction times a fraction, we want to start by doing that multiplication. Remember, when you multiply fractions, you always multiply straight across. So I've got 3 times negative 5, which is negative 15. There's an r here and an r over here, so I want to go ahead and multiply those together. We know that when we multiply two terms with the same base, we add their exponents. So we have r to the 1st times r to the 4th. That would be r to the 5th, because 1 plus 4 is 5. And then the s doesn't have anything to match with over here, so I'm just going to bring it over. Then I'm going to put my 9 out in front, just because I like to keep numbers in front. Then I've got s to the negative 6 times s, so if we add negative 6 plus 1, that's going to be negative 5. Now I've got an s up here and an s down here. One of our properties told us that if we've got two terms with the same base that are being divided, we subtract their exponents. So I've got negative 15 over 9. I've got my r to the 5th. Then I've got s to the 2 minus negative 5. So now in this step I'm going to simplify my fraction here. 15 over 9 can be reduced because they're both divisible by 3. So that would make negative 5 over 3. My r to the 5th has nothing to change. And s to the 2 minus negative 5 would be s to the 7th. And that would be my final answer. So we're going to skip over 4 and 5. I want you to try those two on your own. And then we'll go over them in class tomorrow. So make sure you do those. And we're going to look at number 6 together for our last problem. So if we look, I've got two sets of parentheses. The first one doesn't have an exponent on top of it, so I'm just going to leave that parenthesis alone for right now. So I'm going to rewrite it. My second parenthesis, I've got a squared out here, so I need to square everything in the parenthesis. Now we need to notice that this is a little different. We've got a negative sign in here, just like we did up here, but this time it's being raised to an even power. So we're going to write down that if we have a negative number raised to an even power, the answer is positive. It's important to know the difference. If you ever forget, you can always think about negative 1. Because we know that negative 1 squared, which would be negative 1 times negative 1, that's a positive number. So you can always go back to what you know. So the negative sign is going to disappear because squared makes it positive. Then I've got x to the 4th because 2 times 2 is 4. And y squared because 1 times 2 is 2. Now I'm going to multiply the terms with the same base, so I'm going to be adding their exponents. So I have x to the 7th, and then y to the negative 3rd. And then I can't have a negative exponent in my final answer, so I want to put this in the denominator of my fraction. So I'm going to make it x to the 7th over y to the 3rd. Alright, so that's all I have for you for notes today. Make sure that you try 4 and 5 on your own before class, and we'll go over them. Good luck!